So if you plug those into a calculator, you would get that that is, let's see, negative 5 plus square root of 265 over 20 is about 0.56. I did that in my head. Do you believe me? Then negative 5 minus square root of 265 over 20 is about negative 1.06. So my other solutions up here, one of them is negative 1.06. Does that look like that might be that solution? Sure. And then also the 0.56. Does this one right here look like it's a little bit more than a half? Sure. So all our zeros were negative 1.06, 0.56, and 2. Now here's something to remember compared to what we were doing in the last section. When we were finding zeros, there was a theorem that helped us know how many zeros we were actually supposed to find. It was talking about the degree. So right here, when you've got it set equal to 0, look at your degree. That tells you how many solutions you're supposed to get. 4 solutions, quote unquote, zeros, right? Did I get 4? Yep, I'm done. Okay, this one, let's start with that at the beginning. We've got a degree of 4, so I know I'm looking for 4 solutions. Now, when you look at the graph, I can easily tell that there's one at 0 and there's at 1, one at 1. So I'm going to tell you right now that I've got 2 of those zeros. Now, multiplicity applies with these equations as well. These are just like finding zeros. So if anything applies to that, then it applies to this when it's set equal to 0. Anyways, I can for sure tell there's 2 intercepts. There's no bouncing, right? None of them have a graph that comes down, touches the x-axis, and goes back in the opposite direction. They're both cross-throughs, which means they happen an odd number of times. If one of them bounced, then I would say, okay, one of these happens twice. So what we're going to do is start with what we've got, and then we're going to figure out what the other 2 solutions are. I talked about this yesterday. We'll finish it, and then I'll show you what I mean. So first step is we got to get it equal to 0. It's got to look like that whole function set it equal to 0 thing before we can apply everything we've got. So we've got x to the 4th minus x cubed plus 16x squared minus 16x. Okay, I'm going to use a synthetic method. This one you could factor. You would start with a GCF, and then it's 4 terms. I don't care how you solve it. I'm going to use synthetic division on this just so you can practice what we were doing before. So what number shall I start with? Let's start with 0. Remember, for synthetic division, you're still missing a term if you're missing that constant, right? Missing a constant, the guy without a variable. All right, whole process, multiply, add down, multiply, add down, multiply, add down, multiply, add down. Woohoo! So all we've done at this point, I say the word so a lot. Sorry about that. Now we're at x cubed minus x squared plus 16x minus 16. You could stop there and you could do some factoring, or we could continue with synthetic division and try it with this next number, 1. Doing it with these new numbers. I have a constant now, right? That negative 16 right here is the constant. Doing a 1 out here. Following. Let me hear it. Woohoo! Nobody woohooed. Okay, we were at x to the third. Now we're at x squared. X and plus 16. Leaving out the plus 0x. Here's my equation. Easy to solve. Subtract that 16 over. X squared equals negative 16. Got a square root. Oh, didn't work, did it? X equals plus or minus square root of negative 16. All right. We've got a negative. That means there's going to be an I. Then we've got the square root of 16, which is 4. And 4 goes out there in front of the I. So these are my other two answers. So all of my solutions to my equations are my 0 and 1. And then my other one are positive and negative for I. That is two values. You can write them as two separate ones if you want, or leave it with the plus or minus. I don't care which one. And um, I think on your assignment it can be either one. Just recognize they mean the same thing. Okay. Oh, that was the last example. Woohoo! Okay, so the basic idea here is after you learned how to find those zeros, you knew how to solve equations. The only difference is it's not set equal to 0 yet. You can't just say equal 0 and then solve. You actually have to go through the steps to make it a 0 on one side, like we did here. And then from there, you can use the same methods you just did on finding the zeros. Sometimes it's easy to just factor. Hey, solve it by factoring. Or you can go to the graph and use synthetic division. This is one of those your choice kind of issues. Okay, bye-bye. Bye.